Hi guys, this is Nitya, Assistant Professor, Department of Mathematics from St. Anne's Arts and Science College. Today we are going to see the Cauchy sequence part 2 theorems. First theorem, if Sn is a Cauchy sequence of real number, then Sn is a convergent. So, they have given that Sn, the sequence Sn is a Cauchy sequence. Then we have to prove that the sequence is convergent. We know that convergent means it has a limit. Okay, as per the definition of convergent. So by the lemma, that is by the lemma in the sense here, by the previous theorem, that sequence Sn is a Cauchy sequence of real number, then sequence Sn is bounded. Yes, we had seen in the last class that is a theorem that if the sequence is a Cauchy sequence, then the sequence is called as a bounded sequence. So therefore limit superior Sn equal to limit inferior Sn or finite near number. So since we are taking this as a bounded, so we are taking the limit superior and inferior. Hence we prove that the theorem is enough to prove limit superior Sn equal to limit inferior Sn by the theorem. Yes. So we know that limit superior Sn is greater than or equal to limit inferior Sn. So we can take this as a first equation. We know that yes, superior is greater than or equal to inferior. We know very well. Thus we need to prove that superior Sn equal to inferior Sn. Since Sn is a Since Sn is a Cauchy sequence for a given epsilon greater than 0, the axis n belongs to I such that modulus of Sm minus Sn is less than epsilon by 2 and modulus of where m comma n is greater than or equal to n. So, this follows that Sn plus epsilon by 2 and Sn minus epsilon by 2 are respective upper and lower bound. Now, the sequence Sn comma Sn plus 1, this is by the limit superior, right? Limit superior sequence Sn. So, this implies Sn minus epsilon by 2 is less than or equal to GLB of this term, which is less than or equal to LUB, yes. So, therefore, which is less than or equal to Sn plus epsilon by 2. So, we must have that LUB of that sequence minus GLB of that sequence less than or equal to epsilon. So, LUB of that sequence less than or equal to GLB of that sequence plus epsilon. Now, taking the limit n tends to infinity on both sides, so we will get limit superior Sn equal to limit inferior Sn plus epsilon. Since epsilon is a small, arbitrary small, so we can omit it. So limit superior Sn is less than or equal to limit inferior Sn. So this you can take it as a second equation. So from the second equation, if you are applying that limit superior Sn equal to limit inferior Sn, so hence proved. Next we can move on problem, that is evaluate for n belongs to I, let Tn equal to 1 plus 1 by 1 factorial plus 1 by 2 factorial and up to 1 by n factorial. Prove that the sequence Tn is a non-decreasing and prove that the sequence Tn is a bounded above, and the proof that the limit Tn is greater than or equal to limit 1 plus 1 by n the whole power n. See the first one A, that is Tn. Tn is a non-decreasing. We are going to prove it's a non-decreasing. So let us given that Tn equal to 1 plus 1 by 1 factorial, likewise they have given. Now Tn plus 1 can be written as 1 plus 1 by 1 factorial, 1 by 2 factorial and 1 by n factorial plus 1 by n plus 1 factorial, which is greater than or equal to 1 plus 1 by factorial up to which is equal to Tn. Yes, Tn plus 1 is greater than or equal to Tn. Now Tn is a non-decreasing, therefore Tn plus 1 is greater than or equal to Tn means, suppose if you are applying any value to, suppose T2 plus 1 is T3 is greater than T2, so for all n, so it's a non-decreasing in the sense it will be increasing only, 2 3 4 it will be increasing. Obviously Tn is a, that is a sequence Tn is a non-decreasing. Second one, it's a bounded above, right? Bounded, second one is a bounded above we have to prove. So let us take the Tn given term and then 2 equal to factorial 2 equal to 2 and factor 1 by 2 factorial equal to 1 by 2, 3 equal to 2 squared. So 1 by 3 factorial equal to 1 by 2 squared. We are taking like this. Okay. So Tn equal to 1 plus, this you can take it differently, that is 1 plus, this is 1 by 2, then 1 by 2 squared and so on up to 2 power 2n minus 1. So Tn is less than 1 plus, this is a general term we are writing, 1 minus 1 by 2 the whole power n by 1 minus 1 by 2. So Tn is less than 1 plus, this can be written as 1 minus 1 by 2 power n divided by 1 by 2. This is 1 minus 1 by 2 is half, that is half. Then 1 plus 2 into So this 2 into 1 minus 1 by 2n, denominator 2 should be carried over here. So 2 minus, this is you have to cross multiply, so 2 power n minus 1 by 2 power n. Now it will be like this, that is just multiply, you just multiply 2 into 1 is 2, and 2 into that is 2 by 2 power n will come, multiply 2 in the both terms. So 1 plus 2 is 3, minus 2 power, this n should be to be carried over on the top term, so 1 minus 2n. So this is 2, you can neglect this term. So 2 power 1 minus n is a very arbitrary, so you can leave it. So take the whole number, that is 3, so Tn is less than 3, therefore Tn is a bounded above. Tn is a bounded above sequence. Next one, let Sn, for third thing, Sn equal to 1 plus 1 by n whole power n. Using binomial formula, we know that x plus a the whole power n equal to x power n into nc1 x power n minus 1 into a, nc2 x power n minus 2 into a squared. So 1 plus 1 by n, you can split like that, you can write like this, and then this can be written as 1 plus 1, then n into this can be written as n into n minus 1 by 2 factorial into 1 by n squared. So take n squared should be outside, so what will happen, 1 plus 1 by n has to come. Likewise n power cube, we can take it outside, the remaining term will be like this. So it can be Sn is less than 1 plus 1 by 1 factorial plus 1 by 2 factorial up to 1 by n factorial will come. Therefore Sn is less than Tn. Therefore if you are applying the limit for both sides, Sn is 1 plus 1 by n and the whole power n. So this limit Tn can be greater than or equal to this one, or both are same, less than or equal to this one. So hence proved. Thank you girls. So this unit 3 completed now. So next class onwards we can move for the next unit. Thanks for watching. Hope you understand. Even if you have any doubts, you just approach.